Now, the handout that you just picked up, I just want to give that to you early. That's the test review for next that we'll do Monday and Tuesday for Wednesday and Thursday. So again, Wednesday and Thursday, we're splitting the test up into 2 days because our it's our EOC schedule. There we go. Here's the bell schedule. I think I sent this out yesterday. I just want to make sure you guys know the schedule for next week. I think they flipped some of the later periods around. It was 6, 7, 1, 2, but now it's 1, 2, 6, 7. So again, your test is going to be Wednesday, Thursday. So we'll have a period Monday, have period Tuesday to do test reviews. So what we're doing today with the confidence intervals, that's not going to show up until the Thursday portion of the test. So your test is 2 pages. Page 1 will be Wednesday. Page 2 will be Thursday. And you'll get to use calculators on both days. Okay, so page 29. Okay, a town takes a poll of its residents to find out how many people would be willing to pay a new tax to repair town sidewalk. Out of 1,100 people polled, only 130 said they were willing to pay by 90% confidence interval for the portion of the whole town that will be willing to pay the extra tax. So let's start off with the formula that we'll be using. We know it's going to be involving that probability formula and not the one involving mean and standard deviation.
We don't have to.
Sorry?
We don't have that for the numbers.
Exactly, yeah, I'll give I'll give those formulas to you. So to find that probability, we have to only, it's like 130 over 1,100, so we know that's our sample proportion there. There's another formula that we have to involve, and that's to help us get to the Z score. So first we have to go through that 1 minus C% divided by 2. We want 90% confidence interval. So 1 minus 0.9 divided by 2. This will give us our probability. Now we can pick the Z score from page 2. 0.05. Closest one I can see is negative 1.64 or negative 1.65. They're both the same distance away. I chose negative 1.65, but negative 1.64 also works. Now that negative is not going to make any impact once you put into the formula because there's a plus or minus in front. So really, we're going to have to involve both plus or minus. Okay. Any questions so far? So we have all the information that we need for the formula now. What's our n value? 1100, right? So total number of people in our sample size. Enter all this into your calculator, get a decimal value. So I want to keep reminding us here, what do we call this number here? Good, that's the margin of error, right? Because we know that this is the poll that was taken, but how accurate is it, right? We got to give ourselves some room for error here. So that margin of error is going to allow us to spread out our interval a little bit out. So now our confidence interval, we just take our value. Yeah, question.
Where did you get the 0.118 from?
0.11. Yeah, so 0.18 is coming from that probability.
Okay.
Yeah, so we
Just
do.
put that in
Yeah,
calculator.
just put that in the calculator. 130 divided by 1100 is 0.118. Sometimes they give you the percentage outright. If that's the case, that's your sample probability. But if they give you two numbers there, we got to find that probability. Okay, so our confidence interval is going to range between two values. If I do 0.118 minus 0.01604, that's your lower bound. And if I do 0.118 plus 0.01604, that's going to be your upper bound. So the upper bound is going to be 0.1340. So with a 90% confidence, we can say that the actual proportion of people who want to pay that extra taxes would be somewhere between 10 and 13%. Even though the poll shows that it's 11.8%. Right, but that sample doesn't represent the entire population. It's just the number of people polled. Okay, so then part B, we're using that information that we gathered. It says if 15,000 people live in this town, then we are 90% confident that between what two numbers will be willing to pay this tax. So we can do 10% of 15,000, and we can do 13% of 15,000, and then find that range of values. So we know 10% or 10.2% of 15,000 people, that's 1530. And then 13.4% of 15,000 is 2010. So between 1,500 and 2,000 people are willing to pay this tax. Out of the 50,000. Oh, yeah, the first two pages is a test review for Wednesday, and then the third and fourth page is test review for Thursday. All right, moving on. Number two, company that produces white bread is concerned about distribution of the amount of sodium in its bread. Company takes a simple random sample of 100 slices of bread and computes the sample mean to be 130 milligrams of sodium per slice. Construct a 99% confidence interval for the unknown mean sodium level, assuming that population standard deviation is 10 milligrams. So with the information that's provided, we know that we're working with that second formula. So let me write out that second formula. It's going to involve standard deviation and mean. So we know that we're using this formula because the problem presents us with mean and standard deviation. So we know it doesn't fit the other formula because it doesn't have the information provided for the other formula. So a sample of 100 slices of bread. Let's see. So that's our n value. Sample mean 103 milligrams. That's our x bar. 10 milligrams, that's our standard deviation, that's our sigma. And then from that 99%, we can work towards our z-score. Okay, so 0.005, go to page 2. Find the z-score that's associated with that probability. That's page 2. We can either choose negative 2.57 or negative 2.58. I chose negative 2.58, but either is fine. Okay, everything we need is in front of us. Put into our formula. Okay, so that 2.58 is your margin of error. .103 minus 2.58, that's my lower bound. the 103 plus 2.58, that's my upper bound. So we just carry that down to part B, that's our answer. Okay, so then in words, what does that mean? That means we're 99% confident that the vast majority of the sodium level is going to be between these two numbers. Okay, go ahead and try number 3. I think number 3 should feel pretty straightforward. Number 4 is a little strange because we're having to work backwards from information that we usually end up with, working backwards from the end to the beginning. So when we get to number 4, I'll go over that in detail. But have you guys try 3? I think you'll be able to work through 3 very similar way that you did number 2. Okay, here's number 3. You work for a consumer advocate agency and want to find the mean repair cost of a washing machine. In the past, standard deviation has been $17.50. Part of the study, you randomly select 40 repair costs and find the mean to be $100. Calculate 85% confidence interval for the population mean. So sigma is 17.5, n is 40, x bar is 100. Okay, so we're using the second formula there, x bar plus z, sigma over root n. We want 85% confidence interval, so we have to get to our percentage or probability from the probability, get to our z-score. So 1 minus 0.85 divided by 2, which is 0.075. Use the table to get to your z-score, negative 1.44. And now we have everything we need. So x bar plus or minus z times sigma divided by the square root of n. We get plus or minus 3.9844. So we have 85% confident that the average repair cost for a washing machine is somewhere between $96 and $103.
For the 85% confidence, what if we do 1 minus 0.85 divided by 2?
Which is 0.075.
I got 0.5 somewhere.
Okay, let's try it. I got 0.075. And then from 0.075, you go to your z-score, you'll get 1.44. Yeah, try it again, see if you're getting that.
Just subtracting. Okay.
Yeah, use your n over d feature so that you get all this in the numerator and all this in the denominator so that. Okay, any questions with 3? Okay, number 4, it's a little bit different. Let me read the problem here. It says you want to estimate the mean fuel efficiency for all Ford Focus cars with 99% confidence and margin of error of no more than 1 mile per gallon. So here it's a little bit different because normally we're trying to find the margin of error. Here, they're telling us what the margin of error is. Preliminary data suggests that sigma is 2.4 miles per gallon is a reasonable standard deviation. How large a sample do you need? So we're looking for the n. Typically, we have the n number of the sample size and looking for the margin of error. Here, we're given the margin of error and going backwards to figure out the n value. So your margin of error is just this portion, right? It's what comes after the plus or minus. So we're just working with that portion to get to what we need. Okay, so let's start with that formula. Margin of error is z times sigma over root n. Okay, good so far. All right, let's gather some information here. Margin of error is no more than 1. We'll just say that's equal to 1. Sigma is 2.4. We'll have to figure out our z-score. We'll find that information in a second. And we're looking for n, right? That's our ultimate goal here in this problem, looking for n. All right, so from that 99% confidence percentage, we can get to our z-score. Which is 0.005. Okay, let's find the corresponding z-score from that probability. Either one here, negative 0.257 or 2.57 or 2.58. I think I chose 2.58. Okay, so let's insert this into our formula here. So margin of error is 1. Z sigma divided by square root of n. Okay, so let's just make this a algebraic problem. I'm just going to cross multiply and then try to make my way down to solving for n. So if I force that as a 1 over 1, I can cross multiply and do cross product. 1 times negative 2.58 times 2.4. Negative 6.192. Right, what can I do to both sides to get n by itself? Square, not square root, but square, okay.
Okay, square.
So I want to undo that square root, so I'm going to square both sides. What's going to happen with that negative? Becomes positive, right? So n equals 38.34. So how large a sample do I need? I need greater than or equal to this value. So n is greater than or equal to 38.341 in order to earn that margin of error. So sample of at least 39 cars of this model. So I got to round to the nearest whole number here.
Do you want us to round?
Mhm. Okay, page 20, sorry, page 30. So page 30 was kind of putting things together from previous sections as well. The actual time to cook a 10-pound turkey is a normal random variable with a mean of 2.8 hours and standard deviation of 0.24 hours. Suppose random sample of 35 10-pound turkey is taken. What's the probability that a randomly selected 10-pound turkey will take less than 3 hours? Or less than 3.1 hours. Okay, so we can find the probability. We know less than makes it a little bit easier because whatever we get from the table is our value. Okay. So we want to find the probability of x is less than or equal to 3.1. This is not gonna land on our bell curve, so we have to rely on z-score.
One point two five, the probability is.
It's a z-score. So we want to find the probability. So that's a positive 1.25. So we're gonna look on page 3. So 0.8944. Okay, what's the probability that will take between 2.7 and 2.95 hours? So we'll find both z-scores, both probability at those values, and then we can subtract the probabilities at the end. So find z-score twice, look for 2 different probabilities from 2 different z-scores, and then we'll subtract the larger minus the smaller. So A and B is review from the previous, from the earlier portion of our unit. And then part C, we get to confidence intervals. Page 2, find your z-score from for the confidence interval. Yeah, I know we're going a little long today, but I want to make sure that we're really comfortable. So let's see if we can get through all of page 30. Okay, and I'll just work as you guys are working through the problems as well. Any questions so far? Everybody okay with 5? Number 7, just be careful that, it's not 95 over 395. What adjustment do we have to make? Yeah, 300 over 395. They're asking for not those who bought the stores in the magazine, but those who have subscriptions, so it's 300 over 395.
You will minus 0.99 by 1 would be 0.8.
For which number?
For number 7.
Oh, yeah, you're right. You're right. Oh, wait a second. You're right. Sorry. I put the wrong numbers down. Thanks for that correction. Let me change that. I was copying from the previous problem. You should still get the same interval though. Let me know if that makes sense to you guys. Okay, last part here, part 8, number 8. Fill in the blanks for one of the following for how the margin of error is impacted. Is it going to increase, decrease, or stay the same? So number 8, it says, as the sample size increases, what's going to happen to the margin of error? So if I keep increasing n in the denominator, what's going to happen to my overall value?
Accurate.
Well, is my value going to increase or decrease or stay the same? Those are my options. Yeah, because as my n is getting larger in the denominator, that's going to force my fraction to get smaller and smaller. So yeah, decrease. Imagine this n was 1 versus 10 versus a million, right? That fraction is going to get smaller and smaller. You're dividing by a larger number. Okay, as the confidence interval increases, what's going to happen to the margin of error? The margin of error is going to increase, right? So basically, if you create a larger and larger target, you're going to have a higher confidence that someone is going to meet that target, right? So you want your margin of error is going to keep widening, which will increase your confidence level or confidence interval. Okay. As the standard deviation increases, the margin of error increases, right? So standard deviation means that, you know, you're widening your margin of, standard deviation and margin of error are very much related. So if you increase the numerator, your margin of error is also going to increase as well. Okay, you come and get your phones. Okay.